Hello, hello.
Hey, we're live.
We are live, demo days. It's Friday, 2 p.m. Eastern, 11 Pacific. Rob, how's it going?
It's good. I have to use a virtual background because I have so many children that I am in my bedroom, and I thought that would be weird.
Love it, love it. Well, I actually am in my bedroom, so you can see my plain blue wall here and my plants here in my small apartment, but
Does
this
that
is
wall
awesome.
flip down into a Murphy bed? Is that like all 100 square feet they give you in DC?
Potentially. Not sure yet. It's a little thin for that. But I heard about this awesome thing called GitHub Container Registry. Rob, you and I were talking about it a little bit. I heard it's got a little security to it. It's got some container flexibility and enhancements. Tell me a little bit about this container registry that you wanted me to look at for this application.
It's a nice setup. This is interesting because to go back a little bit before I jump into this, it probably is relevant to talk about our background. So me and Andrew, in the container space, I say we are at least knowledgeable enough to discuss it at some depth. Me and Andrew have known each other for, I don't know, we've been working together for 2.5, 3 years, something like that, right?
Yep.
And we first met at Docker. One of the folks that helped make containers really usable. And one of the things that was really exciting now that we're at GitHub has been, their embracing of, that container ecosystem. And so now with the launch of GitHub Container Registry, and I was super excited to see like what was our take on it, how did we do it, what ways is it kind of differentiated and special, and it's like I said, it's one of the things I've been really excited for ever since I started GitHub is to have this type of capability to kind of bring not just our code, but to be able to take our compiled artifacts, and in this case, our images, our container images, and be able to store them in one place.
Yeah, absolutely. And containers have been around for quite some time, and lots of folks have been using containers, out on Docker Hub, and also recently with GitHub Packages. But one of the things that individuals and entities are concerned about is, of course, security. Security is top of mind for a lot of folks. We've got all these containers out there. How do we prevent things like container sprawl and ensure that the software we're packaging into those containers is secure? And I think that's a lot of the impetus too for GitHub Container Registry, is really expanding upon that vision we have with GitHub Packages and really digging into this space, especially from a security perspective. You got any comments on that, Rob?
Oh, I mean, you are the most security focused person I know. So basically, anything you want to do with security, that's the direction I'm going. I'm following your lead all day.
Love it. So we've got an application here that you and I have been working on. We've got the blog post up with the recent launch of GitHub Container Registry, and I've been reading about some of these security enhancements around access control. So what we want to do is let's try to set this up. Let's try to wire this up to our repository that we have. And I've got a sample code base here. This is just a simple Node.js backend with an Express API. It's also using a React.js front-end client. Super simple application, and I'll run it here shortly. But Rob, you and I have been working on this together. We've got a couple of issues up, and you called me out. You said I'm the security guy. You said this is something that I should look at here, and we've got a few things we have to configure. We've got some static code scanning that we have to address, some deployment tasks, it looks like to a Kubernetes service running out on Microsoft Azure. Anything else here I should take into account as I go through this?
I mean, definitely, number one on the list, dependency vulnerabilities, whether we have, open source libraries that have dependencies that GitHub will automatically find for us.
All right, looks like I got to make this a hacker-free zone too. So this is
and make sure you pay attention.
Take care.
There's important people that have commented in this issue. So follow their advice. But
absolutely,
as per the comment, if it doesn't work, there's one of us that maybe we'll be looking for a new thing.
Absolutely. And it looks like too a couple of these security vulnerabilities were detected. Let's take a look at what these look like. It looks like. I know you're not necessarily as up to speed. When was the last time you wrote some JavaScript? It's been a hot second, right? Yeah.
JavaScript? You mean, is that when you write something while drinking coffee?
Potentially.
In that case, often.
Yeah. So we're gonna keep you away from, I guess, the source code specifically. But It looks like here, knowing what I know about this application, there's some client-side dependencies that have some vulnerabilities associated with them. If I dig in here, it looks like HTTP proxy dependency needs to be version bumped, but it also looks like GitHub has done some version bumps for me with Dependabot. So we can definitely merge these in, review these locally, and make sure we fix these. What else do we have to set up here?
Well, I was just going to say that is an awesome feature of GitHub that I think a lot of people don't recognize is the idea that, hey, you know, we're all using open source packages and open source dependencies throughout our code to be able to develop faster. And we you know, we're not always necessarily on top of you know, what do we need to address? Where are there vulnerabilities that have been found? So by GitHub kind of helping us out, you know, makes for some more secure code.
Absolutely, absolutely. And it looks like static code scanning, we have to set this up as well. Can you talk more about some of the static code analysis capabilities too that we have available?
Yeah, GitHub Advanced Security, which is now, that might be actually, maybe that's a mistake. Maybe we don't call it that anymore. It's hard to keep track of all our shits. But yeah, static code analysis goes as kind of a step beyond Dependabot. You know, that was our first step as we started focusing more and more on security here at GitHub. And what we realized is it's great to respond to vulnerabilities that have already been found, you know, been identified in the form of CVEs, but how do we take it a step further and look at our actual code base and identify potential vulnerabilities in custom code? And static code analysis allows us to do that. And it does it in a very kind of GitHub way, in the sense that it's not a black box that says, let me look at a bunch of code and I'm gonna tell you what the vulnerabilities are, but I'm not gonna tell you how I found them. Instead, what we do is we really take your code, or our code in this case, and we build, you know, basically code as data, and we store that in a way that it is reportable. And so we can run queries directly against it using what we call CodeQL, which is a language that can be a query language that we can directly write against our actual data, our code stored in databases. And then we're able to identify when there are vulnerabilities and use variant analysis to find both common vulnerabilities as well as potential vulnerabilities. And these custom queries and the idea that they're adaptable allows us to help minimize the number of false positives we have when we're doing this, because there's nothing that can't eat up your time, like going through, you know, a static analysis tool and spending hours, you know, with 80 or 90% false positives.
Yep. Yeah, 100% agree, Rob. And it looks like here I can take a look at an analysis workflow that's already been set up for me. Let's go ahead and actually do this right now. Let's set up this workflow. So for those who are not familiar with GitHub Actions is our built-in CI/CD capability. And it looks like here that GitHub has automatically filled in all of the YAML configuration and the things that I need to set up the actual code scanning steps. Let's take another look through this workflow here. It looks like it's going to trigger a new CI/CD task every time I push against my master branch and open up new pull requests against master. Or based on a schedule cron job here as well. It looks like it's going to do a scan against JavaScript language, which is what I'm using here, so that's great. Check out my source code. And then do the auto build like you mentioned. It compiles it into that database against which I can run queries. And then it actually does the analysis. All right, so let's go ahead and set this up. And I'm gonna leave the commit message as is. We'll set up an optional extended description. I'll go ahead and create a new branch. We'll call this CodeQL scan. And we'll see how that goes.
It's a good thing we had you do this, because if they relied on my hunt and peck typing, we could be here a pretty long while.
We'll do some code scanning here. We'll say it's going to address issue 6. And maybe I'll assign you as a reviewer here. And create a pull request.
Let me get over there. This is my first Twitch, in case all the viewers out there are wondering why they haven't seen me more often playing like Duck Hunt on Twitch. So I have to wade through all my windows to get in
Love
here
it.
and approve your work. I'm used to approving your work. I'm basically your boss. So let me see.
Essentially, yeah. And it looks like the scan has started, so we can take a look into that. It's initializing code QL. It's checked out my code. And it's doing everything it needs to do here. So we'll let that run. So let's take a look at some other tasks, Rob, while you're reviewing that and figuring out your Twitch
Yeah,
stream.
don't think I'm just gonna rubber stamp it here. Okay, I'm gonna dig deep on this one.
Let's see what we got here. So we also have to do container image vulnerability scanning. But before we do that, let's go ahead and circle back to the application here and take a look at the code we have and what we need to do to actually package this app as a container. So looking through the code base, we've got client-side code and we have backend code. Let's take a look at the backend source code. A simple JavaScript application uses Express.js. We've got a Docker file here. Rob, talk to me about this Docker file. You're also a container guru. What am I doing here in this Docker file? Is this just going to run my app as is?
Yeah, let's see. Here, hold on. I got to get my glasses on. Yeah, so if you guys are ever seen a Docker file, it should look fairly familiar. But if not, you have your initial image that you're basing off here, which looks like you're using a node build. You're setting your working directory on where you're going to put everything. You're copying in your JSON file with your packages, and then you're running npm. So you're installing npm. I haven't looked at this yet, so then walk through it. We're exposing a port so that we can actually expose this outside of the of our Kubernetes cluster. We're copying everything in the directory, and then we're running a command.
Awesome. So yeah, it looks like it's gonna package up the app, make it available as a container once we run it. Let's see here. Anything else that we need to take into account? Oh, we've got some code spaces stuff here. I guess we'll dig into that in a bit. Let's take a look at the client-side container as well. It should look about the same. Yep, as you mentioned, Rob, it's gonna set a working directory in the container. It's gonna copy over my dependency manifest. Looks like we're doing some finagling here around the host routing. I guess we'll get into that in a little bit. Oh, this is pretty cool. Looks like I'm using, if you're familiar with the multi-stage build, Rob, right? With the build steps and a separate step from the actual runtime.
Yeah, this is ideal for minimizing the size of your container images and speeding up how quickly you can kind of pull these things down from container registry.
Yeah, so I heard that's pretty important too from a security perspective. I want to ensure that my container running out in the wild on a cluster is as small as possible. Why is that important from a security perspective instead of just using the bigger image here?
The concept is the idea of minimizing the things that or the points of entry, your attack surface area. So the less moving parts you have that you don't need, which is what's in these large images that are built to actually compile your job, there are more places there can be vulnerabilities. So if you limit your actual container image to just the functions and procedures that you actually need, that's going to reduce your attack surface area and make it a more secure system.
Absolutely. Yeah, and we're using just the Nginx web server here to actually serve out this content, which is a pretty lightweight container. They have some variants as well that are based on Alpine Linux, which makes that image even smaller. And there's a lot of creative things that you can do here from an image standpoint for optimizations. So it looks like we've got some images. And now what I want to do is I want to test all this out locally here. So I've got my command prompt and I've got the repository opened here as well. Let's make this a little bit bigger. So I've got all the same files. My code is pulled down. I've also got a make file here that'll kind of assist with some of the build steps. And for those that are new to containers, in order to take our Docker file and turn that into a container, we have to build it first and create what's known as a container image. That image is then subsequently pushed to some registry. And then from that registry, we can, of course, deploy that as a running container. So it looks like I've got the build steps ready to go here. If I do a make build, it should go ahead and build my images locally. I happen to be running the Docker desktop tool, which is an awesome free to download desktop client with Docker prepackaged and ready to go. It even includes a Kubernetes cluster that you can spin up on your local workstation, works across Mac OS and Windows. There are tons and tons of options for using Docker locally, of course. There's Minikube on the Kubernetes side. You can use other OCI or Open Container Initiative compliant builders and specifications. Tons of flexibility here. And it looks like it's packaging up my app. Running through the npm install process that you mentioned, Rob.
As we watch that, I will tell you, after thorough review, I have approved your pull request.
On my container scans. What were the results? Have you taken a look? Oh, I got a green check mark, so that's good. Let's see here. All right, code QL, let's analyze. We've got some results. Yes, so we haven't merged into the base branch yet. So assuming once we merge this in, you've approved it, we should be able to do some results reporting.
Yep.
But it looks like the scan was completed, which is nice. So I'll go ahead and merge that in so we have that going. Acceptable, love it. Let's merge this in.
I don't like to give you too much praise, you know. I mean, your apartment's not very big, so I want to make sure there's plenty of space for your ego.
I'm a wise guy here. Appreciate that. Appreciate that. Let's see here. So that has been merged. Let's go ahead and close that out. Now, of course, we could use a project board and automatically close this, but for this simple project, we'll just go ahead and close this out. So we've got our container.
For anyone interested, I will tell you, I just got a notification on my GitHub mobile app that was completed.
Awesome.
Who wants to check GitHub
mobile app out?
Yeah, it's great.
So we've got our images built, and now what we want to do is we want to push these. So this makefile I've put together also has the registry endpoints that we want to push to. Now with the new GitHub Container Registry, for those that may be familiar with GitHub Packages, there is a new endpoint that you're going to want to push to. And the endpoint is going to be specific to either your user handle or your organizational handle that's associated with your repositories. So the endpoint is going to be ghcr.io/octodemo, and then your image name specifically, and then whatever tag you want to give it. Now, when you push here, so I'll go ahead and do a make push, and I should already be authenticated. Not, I may have to just use the images that are already out there. I believe my token may have expired, which is fine. We got the images out there already. But once the image is pushed out there, let me show you what that looks like. It'll show up in your packages tab, and it'll be filtered out by type container. So the Docker filter is for the Docker or the GitHub packages format. Of course, we encourage folks to migrate to this new GitHub Container Registry where possible. And we have some migration steps that we published to our documentation. And it's as simple as changing the endpoint and then pushing your container images to that new endpoint.
Yeah, I think that's important to emphasize, right? The switch, if you're going from, you know, Azure Container Registry or from Docker Hub or wherever it might be, you know, we've used industry standards here, so you're really just changing the endpoint. It's a pretty easy transition, and there's not a lot of recoding or work involved in getting your stuff moved over to here.
Yeah, absolutely. And the other thing to keep in mind with Container Registry, so when you first push the image, now this one has already been pushed, it'll prompt you on the summary page whether or not to link it to a specific repository. So that's the other difference from going from GitHub Packages. GitHub Packages is going to push the package directly within the space assigned to that repository. In this case, you have flexibility to link this to different repositories as needed, and then assign access as needed. The use case for that is if you have a kind of a global base image. Let's say I wanted to have a specific version of Nginx that my organization is going to use, then I can push that here as well. And then in the package settings, oh, go ahead, Rob.
No, I was just going to say that capability is super important. You know, we talked to a lot of folks, and that's something that they really wanted, because it's sometimes it's, hey, I want a base image that I can use across my entire organization, and sometimes it might just be, this is my preferred node image that I'm going to use to base all of my various projects on. So it can be as kind of as broad or as skinny as it needs to be, or wants to be.
Absolutely. Yeah, and these are some of the new access control functions here. So right now I'm the only user with access to this image. So Rob, I think if you tried to access this, you won't be able to in this particular case. But of course I can invite.
Very selfish of you.
Yeah, I know. What can I say? I mean, in this case, I can certainly invite you to access this image, but I don't think we're going to do that. I'm a little security conscious here. So of course, these are some of the new access control functions, and they work very similarly to how we do access control across the rest of GitHub for repository permissions. And then, of course, within GitHub Container Registry, we very much treat it like a traditional OCI compliant container registry. So I can see the tag push, the SHA-256 digest associated with that image, and then I can drill into that tag specifically, provide a description. In this case, I don't have one. But most importantly, I can see the manifest, which describes some information about the different layers in that container image and ensure that it matches up for integrity purposes.
In a related but unrelated comment, for those security conscious folks, you should all know that Andrew Weiss is planning to name his first child with just its SHA-256 SHA.
Absolutely. 4F250268, I think, is a good first name.
That's solid. That's solid.
Let me see here. So we've got the image pushed. Now, the other thing I want to do, so we've got the code scanning going. Now what we need to do is we need to create a workflow to actually build and test this code and push it out as a GitHub action. So what we're first going to do is we're going to create a new workflow, and we're going to leverage some of the templates that GitHub also provides us. So it sees that I've got some Node.js, and there's some organizational workflows that have already been built for me from this organization. I'm going to start with the Node.js workflow. Let's take a look at what this looks like. So again, it's going to initialize this workflow based on whether or not it's pushed to a specific branch. It's going to check against different versions of Node.js. In this case, let's just do Node 12. We'll do 12 and 14. How's that? It's going to check out my code. It's going to check against those versions. Now run npm tests. One of the things I need to do is I need to make sure that this particular step runs with a specific environment variable. And this is going to be CI is true. It's autofilling for me there. Now the reason I'm doing this is because the unit test engine I'm using on this particular app, and Rob, if you had written some JavaScript recently, you would probably know this, but I know it's been a while. We are using a test runner, which opens up an interactive prompt. In this particular case, I want to run this in a headless fashion. So that way my unit tests will not stop the workflow.
Yeah, well, you're busy writing JavaScript. I'm busy throwing shout outs to my boy Moose, my boy Kevin, Ayamba over on the chat. See, it's just as important to be writing things in chat and using emojis as it is writing JavaScript.
We're going to call this bold, and we'll also create a pull request. Now, there's tons and tons of tips and tricks that you can take into account when building actions. Now, we're doing this on the fly, so it's likely we'll probably run into some errors here, but there's definitely some approaches that you can take when building GitHub Actions. Create node builder. What I typically do is I'll do everything, of course, on a separate branch instead of working through the central and main branch. And it's a good way to kind of test and iterate against the action. It's likely that unless you have a super sound, ready to go action workflow already built at your disposal, you're probably going to run into some errors, and there may be some trial and error. I think this is just kind of a challenge with any sort of CI/CD system. As you can see here, there's already some failures and some things that I'm missing.
Yeah, and on that note, they were, folks really should be. I mean, this is the beauty of GitHub, right? You should be starting with ideally with some of the community actions that are available. So, we talk about if you're deploying to AKS like we are in this instance, being able to reference back to the AKS action that was developed by the Microsoft team and using that as a foundation to build off of. That's one of the great features of GitHub, that feedback loop, which allows us to utilize the best of the community is built, and ideally then we're then contributing back, and helping make those things better.
Absolutely. Yeah, so I can clearly see my error here. I forgot to set the working directory for my package.json manifest, so it doesn't even know what to build. So that's something that we can address here within the pull request flow. So let's see here. Let's go ahead and just pull this down to my let's check out to the node build branch. Okay, so now we've got this workflow locally. And what we need to do is we need to change the working directory for this particular command. And the nice thing about editors such as Visual Studio Code is that we have plugins to support things like IntelliSense and syntax highlighting for your GitHub Actions workflow, as you saw there. And I'm going to use relative path syntax here, and we're going to do, let's see here, backend.
I'm disappointed in your lack of use of code spaces.
Rob, you might be breaking up. I think what's going on with your internet over there?
Well, I have 47 kids doing virtual training or virtual learning on it simultaneously with us.
Oh, maybe it's my internet.
Yes. Your girlfriend's probably in another room.
There it is. My phone. I think so, yeah.
Now, there's a question.
So we got the working directory set.
We had a question as far as using local actions. Can you test actions locally?
Yeah, so there is a tool that you can do that. I don't have the URL off the top here, but there is a tool that you can use to test actions locally for the different steps that you have, but you can essentially lynch your actions based on the latest schemas that we provide. I highly recommend the GitHub extension for GitHub Actions for Visual Studio Code. It's a great way to kind of walk through things and see errors that you're writing locally. But there is a tool, I'm blanking on it on the top of my head. But Rob, if you can think of it, feel free to send it to the chat.
Yeah, I will. I'll send the chat once I'll just look it up.
Excellent. So we've got a change here. What I'm going to try to do is this should fix it. Workflow. Push. And this should trigger a new job here. Refresh. And notice it's going to run both of my workflows, so it's going to execute another code scan, which is awesome. And we'll see if it picks that up. So while those workflows are running, Rob, what's the other thing we have to do here? You've got a few other tasks here. So, we've got to deploy this thing. So we've got to test it. We've got to deploy it. Now, before we deploy it, we need to actually create those deployment artifacts using Kubernetes. And every time I think of Kubernetes, all I think about is YAML, 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 and lots of YAML. So,
more YAML.
Rob, talk to me about all this YAML that we've got here in the repository. I've got, let's see, aks.yaml. Walk me through what we've got here. I know we've got a 2-tier app that I can run locally. I don't think I've showed that to folks. Let's see. Let's actually run that locally before we do some stuff here. So let's go into the back end. We'll do an npm start. And we'll go into the client-side code. And we'll do an npm start as well. And this should spin up a development server and open it up. By the way, this app was created using the Create React app framework, which is pretty awesome. Great way to bootstrap some apps. So this is just the default landing page that it gives you. And I think I've got some console queries here. Oh, excellent. Yeah, so it's looking to make a request. Of course, I have CORS enabled, so it's going to block that request, which of course I can allow as needed here. So let me see here. Client host, what I'm going to do is I'm just going to comment this out for now. We'll go ahead and I can, we're going to restart the back end. I'm including credentials as well. Well, we'll assume that API works out in production, right? Isn't that what they say, Rob? You test it in production?
That's how I always do it, if I test it at all.
Yeah, exactly. So we'll go ahead and uncomment that code. Clearly, I've been trying to get it working in production previously, and I've run into some cross-origin or research sharing issues. But you get the gist of the app, just simple front end. It's going to make a request to a simple API backend. But going back to what we need to build here, talk to me about the
We go back to the YAML?
route. Yeah, let's do it.
Yeah. All right, are you gonna pull it up? You show it, or you have it? Yeah, go ahead and pull it up so we can see it.
You should be able to see it.
Let's see. Oh, yep. All right, so pretty basic. Two-part app here. If we have two sections of our YAML. We have our deployment, which is really the instructions on what we want to put out there. The two containers we have. So if you go down there and you'll see time deployment, and then we have under containers we have two separate pieces. We have a front end, which is the client, and we're exposing that on container port 80, and then we have a back end service exposed on 3001. So that's the first part of your KTML, and that really works in the sense that it will stand up your pod, but you're not going to be able to do anything with it without the second piece. And the second piece is the service. So on the bottom end, you have our service, and in Kubernetes, that's how we actually expose something to the broader world. And in this case, we're using a type of load balancer. We're using AKS. Load balancer works really well, just right out of the box with load balancer, and that's going to expose it to a public IP. So that'll create on AKS that when you include that service, it'll go ahead and automatically create a public IP and expose that on the ports you've dictated, which you'll see right on the bottom. 80 for the web front end and 3001 for the back end.
Awesome. Yeah, and I'll echo your comments about the load balancer integrations that work really nicely out of the box with the Azure Kubernetes service. Of course, you have lots of flexibility here in terms of how you want to configure your networking and routing, and you can do layer 7 ingress as well, using things like the Nginx controller and so forth. Ingress.
Yeah, and honestly, we would probably go in that direction for something that wasn't a kind of a quick and dirty demo. But for stuff that you need to get up really fast, load balancer works really well without having to do any real extra work on the AKS side.
Absolutely. So we've gone through that. So we've got our deployment artifacts ready to go here, and let's take a look at our build steps. Oh, looks like we had another failure. Probably missing some. Let's see here. The resolution is. Yep. Forgetting to set a working directory for both environments here. So we'll go ahead and do that as well. You can set this at the top level, but just for verbosity.
And did you already cover when you showed the CI action where you had embedded the credentials as a GitHub secret?
Not yet.
Okay. Well, never mind. We're gonna ruin the surprise here.
Yeah, we'll do that here shortly. So we've got that action, working through that, dealing with some bugs there. And another action that we're going to want to create is for actually pushing this to a specific registry. And of course, I can look at this marketplace of actions to see if there's any workflows that I can take advantage of. And for those that aren't aware, there's tons and tons of pre-built actions workflows. There's a Docker image workflow, which looks like is one that I can use. Let me see here. There's other ones too for other registry endpoints. So let's go ahead and use this workflow to take a look at what it does for me. So yeah, the nice thing about the hosted compute environment that we provide in Actions is that all the tools you need to actually build your Docker and container images they're all provided. And this helper workflow looks like we'll even tag it with some custom date information. But
what if I wanted to build this image on like ARM? Do we support that?
We do. So so the GitHub Actions hosted compute environment here, we provide all x86 on macOS, Windows, and Linux. But if you would like, you can also run your own Actions agents using what we call self-hosted runners. And you can trigger builds accordingly on your own infrastructure. Now, the agents themselves have to run on x86, but if you have an ARM environment that agent then can connect to, or if you have some external ARM building environment, then you can absolutely send the code from GitHub to that environment, facilitate the build, create the image, and do so accordingly.
I love ARM.
I believe you can build x86 ARM, S390 as well, the power architecture for Docker images. Is that right, Rob? Multiple architectures are supported.
Awesome. It's awesome, and you can even do them simultaneously. Yeah, so you can build it with one single action. Go ahead and build multi-architecture apps.
Let's do here. So we're going to go ahead and do this. So we're going to create. I'm going to actually remove some of this. -T is short for tag. And then I am going to call this GCR demo days backend, and I'm just going to use latest for now. But the nice thing is that the templates are there for you. And then, of course, I have to give it a build context, which is going to be the local context of the working directory.
Yeah, when I first started Docker,
now, another step here that I want to. I know. Yeah, it's.
Yep.
It's the way to set the context directory locally. What's that?
Yeah, yeah. No, it makes sense once you understand what you're doing. But when I first saw it, I was like, why is this even required? But notice on the run when he's building it, when he's tagging it, and that's what's differentiating between GitHub Container Registry and pushing to Docker Hub or some other places is the inclusion of the endpoint right there. So that's that ghcr.io and your org.
So one of the things that we can do is inject a secret into our workflow. Is that right, Rob?
Yep. Yeah, built-in secrets management in GitHub. So you can manage these at the repo level.
It should be secrets, actually.
Have you already created, or do you need to go create it?
It should be created here. I'm just trying to figure out the name that I used. Okay. GCR access token.
The shortest possible, quick to find name. Perfect.
Just already got that in there. And I'll use my username, and then I believe it's password standard in, if I recall. It should be a step.
And this action was built by Docker themselves. Oh, this is that where you pulled this action
Oh,
from?
so this is not an action. This is just running commands from within the workflow itself. And let me actually just test the command. And again, this is, you're seeing the process by which I go through and troubleshoot actions and build them locally. So I've got the Docker tools, password dash standard in, and that's right. Okay, so just reviewing this, we're going to check out our code. We're going to build the image in the working directory. Make sure that's the right path. And then we're going to push that. We're going to log in. And we're going to push this. So let's see what happens. Create a new branch for this as well. All right, so they should go ahead and.
I hope it
that
works
workflow.
this time.
Yeah, we'll see.
Mr. Weiss.
I'm 0 for 3, I think.
We were told before we did this that at Twitch they love failure, though. So we are. They must love us.
Oh yeah, we're rocking here. So we're going to build the image. This will probably take a little bit. So now there's so now when we move towards deployment, there are a couple tricks that folks will want to take into account. So you can see here that I've got the access token we're using for container registry. Now, when you create a new personal access token, make sure that's only scoped for read-write privileges for your packages or your container images. You don't necessarily want to use a widely scoped token for this. So that's what I'm doing there. Now, when we move towards deployment to Kubernetes, Rob, there's this Kubernetes config, is that right? And that's just the YAML or JSON configuration artifact?
Yep.
Yeah, so we can, of course, store that information in the repository. And the nice thing, too, is if we have multiple repositories in the org that are using the same cluster, we can create an org or organization scope secret that we can then subsequently access. So that's what I've got here. Now, one of the things you can do here for deployment, let's see here. I'm going to go ahead and create another action locally. Let's do this. Sure, I got all the latest.
So one of the questions we got from the chat was in regards to being able to create secrets for each stage. I mean, you could definitely create different secrets and label them appropriately to cover each stage, but secrets are really at basically 2 levels. They're either at the repo or they are at the organization. So there's a couple ways. I mean, there's no cap on the number of secrets you create. So you could choose that way, or you could migrate between repos as you move from one environment to another and use specific secrets there. A couple options.
Yeah. Call Rob. So one of the things I'm going to do is I'm going to start working on another workflow to deploy those container images from the registry, assuming they get pushed there. Like I said, we're 0 for 3 here. Assuming they get pushed there, and then we can deploy those to our cluster. So what I like to do is, let's actually start, we'll write this one out from scratch. And what I like to do is I typically use an existing workflow for reference if I'm just handwriting these. We'll call this AKS deploy on push. And we'll just say on push, we'll just do on push in general. Typically, you would scope this to a specific branch or other labeling construct. We need to do a job. The job name will be deploy. Say AKS deploy. This is going to runs on Ubuntu. And you can see here the pretty awesome auto completion and IntelliSense for me using this plugin. Highly, highly recommend it. The nice thing though too about GitHub Actions is that, you know, we try to keep the actual syntax pretty light. So the number of properties we use is really not overly complex. It's easy to get started with if you are trying to handwrite it. You know, I equate that to kind of the nesting here. You see, there's really not a lot of nesting, and that's on purpose. We're trying to make it as simple and digestible as possible. So in this case, I'm not going to use a strategy. I am going to do some steps here. So I'm going to copy, do the checkout step from here. Another thing that I've got. Now let's see, what other step do we want? So we don't need anything from anything else. So one of the other steps that I like to use is I like to stage the kubeconfig artifact for the rest of the jobs to leverage. So what I can do is I can make a directory, and this directory in this whole compute environment is going to live for the lifetime of the whole job. So once I create it once, all the subsequent steps in this job can view the directory structure as is. And what I can do here, and let me see here, got a couple of things written on the other screen. I'm going to go ahead and I'm going to pre-stage some environment variables here so you can see how else you can load these this data up. So you can also set environment variables from secrets as well, which of course are still protected. And I think we're calling this just kubeconfig.
Yeah, I think that people get wrapped up in the word secret and forget that there's a lot of flexibility in how you use that, and you can pass, config files, you can pass environmental variables, really any text, you can go ahead and pass through that secret. Especially if you look at the org level and there's something maybe that you want to reutilize a lot of times across multiple repos. You can use the secrets to pass that information.
Exactly. So you can see here, I'm just pre-staging the kubeconfig into my local home directory that's created for the life of this build. And because the kubecontrol or kubectl, there's that whole industry debate as to how you pronounce it. I like kubecontrol personally. You can use the command that's already available in this Ubuntu-based environment to take the YAML file and apply it to my cluster. Now, Rob, I'm depending on you, Mr. Infrastructure guy. You've got this cluster ready to go, right? I assume. You're on mute, so that's not promising.
Yeah. Infrastructure is easy. I'll tell you, the mute button is challenging. It was definitely working yesterday. So we'll see.
All right.
But I have had issues with my Xbox this morning. My son told me. So if Azure's running on the same servers, we may have a problem. We'll see.
We'll find out. All right. So creating another. Oops.
But in Satya we trust. So.
Oops. I'm on the. I'm naming my branch differently. All right, so we've got a new action here, simple action. In reality, your Kubernetes deployments are going to be likely a little bit more complex depending on the approach that you take. This is very much a push-based approach whereby you're going to have a branch that has changes to both the app and the infrastructure code, and then those changes are pushed to your Kubernetes cluster. There's a lot of interesting ways you can do this. You can also take a pull-based approach if you're familiar with concepts such as GitOps, whereby you have infrastructure running on your Kubernetes cluster that checks for changes in your image files and the Kubernetes artifacts, and then pulls those changes in. So very different approaches depending on how you look at it. Most folks are familiar with this push-based approach, which triggers the updates from the Git side. But there's definitely a few ways to look at that. So let's see here. I've got, oh look, we've got a check mark here, so that's good. Go back to our node build.
I love check marks.
Might have to have you review this too. Oh, so now we've got, going back to the beginning here, we've got some code scanning results, no alerts, so that's promising. And And then we've got our CI jobs. Looks like those worked for both node 12 and the tests ran appropriately. It's nice that GitHub Actions provides this web-based log output so I can view things.
Troubleshoot right
Tests
there.
were specified. There are no backend tests. There are no backend tests, so that's why it skipped out on those. We won't build the front end tests. I think folks get the gist there. And then what we need to do, Docker image, let's check this one. We've got a few minutes left here. Yeah, it looks like my my credentials are not working, so I think we'll load this in. We'll do the same approach we did. Let's see here.
It's hard to keep track of your credentials because you're so security conscious that you change them once an hour.
I know, it's a little overwhelming even for me.
And then write them on a card and put them right next to your computer. Standard procedure.
We'll do this. We'll try it this way, see if I can echo it from. All right, so we've got that pushed up. We'll see if that goes. And let's open the pull request for the recent deployment. Now, the nice thing is these images already exist, so even if we don't get our workflow configured, hopefully folks can at least see the application running. I'm a big stickler for casing of abbreviations. And just go ahead and create this pull request. Now it's going to go ahead and see if it ran. That was awfully fast.
It's working through.
Yep, it looks like deployed. So that was really fast. So you can see here that the actual application was already out and running on the cluster. So kubecontrol takes care of all of that state reconciliation for you. So if I had made any changes or we made any changes to the infrastructure, they would be present or identified and then addressed. So the deployment works, which is awesome. Now let's take a look at the information here for my current command line. So I should have my Kubernetes cluster ready to go. Oops. So awesome, I'm connected to the Kubernetes cluster that you've created, Rob, so that's good. That works. And it looks like there was a load balancer created as well. AKS handles all that routing for me. So as long as I connect to this IP, I should be able to.
It should stand right up as long as I didn't screw something up.
Look at that. And everyone out there on Twitch can take a look at this too, and it should work.
Amazing. Everything I did for this worked the first time.
Spot on.
Just throwing that out there, 100%.
What was your role again? I don't remember what.
I am color commentary, which
Love
incidentally in sports, usually that person gets most of the credit, gets paid the best. Also, I was responsible for this 100% working AKS deployment. Well, not the deployment itself, but just the infrastructure underneath it. I'm not gonna, but I'm gonna be humble about it. Okay.
Well, I appreciate your support here.
No problem.
You did a fantastic job with the infrastructure. So it looks like still having issues with just the login. I think most folks gets the gist. Looks like my token may have expired here, as you saw from the very beginning of the demonstration. But essentially, you're going to have different workflows defined for different tasks. You can, of course, combine all of these tasks in the same workflow. You have a lot of flexibility and control over that. But at the end of the day, it all comes down to, one, creating a Docker file that not only works for your application, but is tied to some of the security recommendations out there, such as keeping your container images small, ensuring that the dependencies associated with that application have been addressed for vulnerabilities, because If you package up the dependencies with vulnerabilities with the container image, well, your container image is still going to be vulnerable.
Crap in, crap out. No doubt.
Yeah.
No, this is awesome.
Exactly. So
I feel like I learned a lot today.
Yeah, I think I learned a lot too. Any other, do we see anything in the Twitch chat from folks?
Here's a tricky one. Okay. Mr. Weiss, can you do all of this from the new CLI, from the new CLI?
You can. I don't have the same tasks running here, but you can absolutely use the new GitHub CLI, and I can do issue creation. I can create pull requests and clone repos. You can absolutely facilitate this entire workflow through the new GitHub CLI. So you didn't have to see me go back and forth with the UI.
Yeah, no, that's awesome. Hey, we appreciate you guys all tuning in. Hopefully they'll invite us back sometime to be on this Twitch thing. We'll see.
We'll see. Awesome. Well, thanks, Rob, for helping us out, get this application deployed. We'll keep this up and running for folks that want to keep hammering away at the UI here. Not much to it.
That was awesome. Thanks for doing all the heavy lifting, Mr. Weiss.
Anytime.
I'll see you next time on the Twitch, the Twitchiverse, which may or may not be a thing.